We want to integrate e to the power of x times the square root of 1 plus e to the power of x with respect to x from x equals ln of 3 to ln of 8. Now, what you should do here is let u equal the expression under the square root sign, because that will simplify this integral greatly. We'll go from two terms under the root sign just to a single term u. If we get du dx, the derivative of 1 is 0. The derivative of e to the power of x with respect to x is just e to the power of x. That's one of the standard derivatives. And again, we just interchange dx with e to the power of x to get dx equals du divided by e to the power of x. Just interchange these. So now our integral becomes the integral of e to the power of x times the square root of u times dx, which is du over e to the power of x. And these e to the power of x's cancel out. So basically we're integrating u to the power of a half with respect to u. So we add 1 onto the power to get 3 halves. And we put 1 over 3 halves, or we put this over 3 halves. Well, 1 over 3 halves is 2/3. And I'm going to just substitute back for u. You can change the limits, but I won't do it that way. I'll just sub back in for u. U is 1 plus x. And our limits range from x equals ln 3 to x equals ln 8. Sorry, I should have e to the power of x here. Okay, so we write this out, replacing x with ln of 8. So we get this here. Then we have a minus sign, and we write this out again, replacing x with the lower limit, which is ln of 3. Now what is e to the power of ln 8? Well, the function e to the x and ln of x are inverse functions. So e to the power of ln of 8 is just 8. Similarly, e to the power of ln of 3 is 3. So here we get 1 plus 8 to the power of 3 over 2. And then we have a minus sign, 1 plus 3 to the power of 3 over 2. And I factorized out the 2/3. 1 plus 8 is 9. What is 9 to the power of 3 over 2? Well, this number here is the root. So we get the square root of 9. And the number on top is the power. We cube the result. The square root of 9 is 3. 3 cubed is 27. 4 to the power of 3 over 2 means we get the square root of 4, which is 2. And then we put 2 to the power of 3. 2 cubed is 8. So we get 27 minus 8, which is 19. 2 times 19 is 38. So our answer is 38 over 3. And of course we can check our answer here. In this example, we want to integrate x times the square root of x squared plus 9 with respect to x from x equals 0 to 4. So again, we have a square root of something. Let u equal what's inside the square root. It's x squared plus 9. So to replace dx, we need to get du dx. Du dx here is 2x. So we make dx the subject of this. So we just interchange the dx and the 2x. That's the quickest way to do that. So now we write out our integral, replacing x squared plus 9 with u. We have the square root of u, which is u to the power of a half, times dx, which is du divided by 2x. You can see that the x's cancel, which tells us that the substitution works, and we get a much simpler integral. We're integrating u to the power of a half with respect to u. I've also taken out this half. We've 1 over 2 here. A factor of a half can be pulled outside the integral sign. So to integrate a half, we just add 1 onto a half. That gives 3 halves. And then we divide by this new power, which is 3 halves. We can multiply above and below by 2 here, and these 2's will cancel. So we get 1 over 3. We get 1/3 u to the power of 3 halves. But u is x squared plus 9. So we have 1/3 of x squared plus 9 to the power of 3 halves. And our limits range from 0 to 4. So we plug 4 in for x here. We get 4 squared is 16. 16 plus 9 is 25. So we have 1/3 of 25 to the power of 3 halves. Then we have minus this again. Replace x with 0. 0 squared plus 9 is just 9. So we get 1/3 of 9 to the power of 3 halves. We can factorize the 1/3 out. What is 25 to the power of 3 halves? Well, this number 2 means we get the square root of 25, which is 5. 5 to the power of 3 is 125. This 2 here means we're getting the square root of 9, which is 3. 3 to the power of 3 is 27. Here is another example from 2008. We want to integrate 3x squared e to the x cubed with respect to x from x equals 0 to x equals 1. Now, what we do here is we let u equal x cubed, because we see that the derivative of x cubed happens to be 3x squared. That's very convenient. That means this integral will break down to something simple. So du dx is 3x squared. We rearrange this to get dx. Remember, we just interchange dx with 3x squared, and we replace dx with du over 3x squared. You can see that these 3x squareds cancel out. X cubed is replaced with u, and we're just integrating e to the power of u with respect to u. Well, that's a standard integral. Integral of e to the power of u with respect to u is e to the power of u. We put back x cubed for u, and we use our original limits. So we put 1 in here, we get e to the power of 1 cubed, or e to the power of 1, minus e to the power of the 0 cubed. Well, e to the power of 0 is just 1. So you can see how conveniently that worked out. You know, if we had, say, x to the power of 4 here instead of x cubed, then we're in trouble, because the derivative of x to the power of 4 is not 3x squared. It's 4x cubed. Substitution won't work in that case. Evaluate the integral of 2x over the square root of 1 plus x squared with respect to x from x equals 0 to 1. Now, like in previous examples, we try to let the denominator be u. As a matter of fact, it's easier if we just let u equal 1 plus x squared. Do not let u equal 1 plus x squared to the power of a half, because that's only going to complicate things when we try to get du dx. You know, we'll have a half times 1 plus x squared to the power of minus a half times 2x by the chain rule. It's going to complicate things tremendously. But if we just let u equal 1 plus x squared, then, you know, the denominator is just going to be u to the power of a half, a single term in the denominator, as you saw in previous videos. So if we do that, we then need to replace dx. So as you've seen before, we get du dx, and we interchange dx with 2x to get dx. So we see that dx is du divided by 2x. So our integral becomes, or the integrand I should say, this is called the integrand, becomes 2x over u to the power of a half times dx, where dx is du divided by 2x. And very conveniently, the 2x's cancel out. Again, it's very convenient. Inside the square root sign, we happen to have 1 plus x squared. If we had 1 plus x cubed, then we're in trouble, because the derivative of 1 plus x cubed will be 3x squared. We would have 3x squared underneath here, and then the x's will not disappear. Anyway, okay, let's see. We have the integral of 1 over u to the power of a half with respect to u. Well, that's just the integral of u to the power of minus a half with respect to u. This is straightforward. We just add 1 onto the power. Minus a half plus 1 is plus a half. And we divide by this new power. We divide by a half, or we put 1 over a half. Well, 1 divided by a half is 2. So we get 2u to the power of a half, which is 2 times 1 plus x squared to the power of a half. And our limits are 0 to 1. So we plug 1 in for x, and what do we get? We get 1 plus 1 is 2. We get 2 to the power of a half, which is the square root of 2, so we get 2 times the square root of 2 there. Then we have a minus sign, then we plug 0 in for x, so we get 1 plus 0, which is 1. 1 to the power of a half is 1. 1 to the power of anything is 1, so we get 2 times 1, which is 2. So we get 2 root 2 minus 2, which you can write as 2 times root 2 minus 1 if you want. by letting u equal sine of x, evaluate the integral of cos x times sine to the power of 6x with respect to x from x equals 0 to pi over 2. So we're given a hint here for the substitution. It makes sense that we should choose u to be sine x because the derivative of sine x is cos x. See, cos x comes into this. So we let u equal the function whose derivative is another function that's part of the integrand. In this case it's cos x. So u is sine x, du dx is cos x. We rearrange to get dx. Dx is du over cos x. So we make those substitutions. So our integral becomes cos x times this here. Well, this here is u to the power of 6. U is sine of x, and sine of x to the power of 6 is u to the power of 6. Dx is du divided by cos x, and you can see that everything works out very nicely. So we're just integrating u to the power of 6 with respect to u, which is very straightforward. This is going to be 1/7 u to the power of 7. That's 1/7 times u, which is sine of x. Sine of x to the power of 7 can of course be written as sine to the power of 7 next. And our limits are from 0 to pi over 2. So we plug pi over 2 in for x, so we get 1/7 of sine to the power of 7 of pi over 2 minus 1/7 of the sine of 0. Well, the sine of 0 is actually 0, so that's going to go out. What's the sine of pi over 2? Pi over 2 is 90 degrees, if you like. The sine of 90 degrees is actually 1, so what we have here is 1/7 times 1 to the power of 7, which is 1/7.